on with this problem, what we're going to first do is read what's going on. It says, suppose that $100,000 is invested at 6.5 interest, compounded semi-annually. So we can kind of start labeling things. What will our 100,000 be? What symbol in this formula? Oh, I didn't even talk about the formula. I'm sorry. So A stands for your accumulated amount, okay? P stands for your principal. It's the initial amount that you invested or borrowed. And then this chunk is raised to the exponential power because it's growing exponentially. You always have 1 because you always start with your original amount, and then this R over N is just like the interest, that's growing. So you're going to take your rate in decimal form and divide by how many times you're compounding. So like when it says 13%, but it's compounding semi-annually, you do 13 over 2. So really it's 0.065 is your rate or whatever it may be. And then your exponent is N, how many times you're compounding, times T. Okay? So looking at this, we're investing $100,000. So that's going to be our P, our starting amount. And we're doing it at an interest rate of 6.5%. So that's R. But what is that in decimal form? Divide by 100, right? Or move your decimal to the left 2 spots. So that will be 0.065. You got it. Now, if you put 6.5 or 0.65, 65% interest, tell me where you bank because there's not going to be an interest that high, right? So we got to be careful. And then compounded semi-annually, how often is that? Twice. So N's going to be 2. So the only thing we don't have so far is what is T. And look, that's what they actually have us doing in part A. It says find a function for the amount to which the investment grows after T years. So they just want us to come up with the generic function. And then that way, like part B, they can ask you, okay, you've had it invested for 4 years, 8 years, and so forth. How much is there? So what we're going to do is we're going to do a function A of T, like this, all right? So like f of x, but A of T. And then what do we start with? P, but what is our P that we're starting with?
100,000.
You got it. Our starting amount was 100,000. Times 1 plus R, but what did we say our R was in decimal form? You got it. Divided by our N, but our N was 2 because it's doing semi-annually. Times N times T, and we don't know T. He's our exponent, so that's okay, or our variable, excuse me. So that's just going to be 2T. Does that look okay so far? What my math lab's going to want you to do, though, is take care of any number that you can do math with. What do I mean? All this ugly stuff in here, we can combine, right? So in your calculator, real quickly, take 0.065 and divide by 2, and then add 1 to it. What do you get? 1 point what?
0.325.
That looks good. Raised to the 2t power. So this is what they're going to want. So our initial setup is necessary, but the final answer has that solid base. We have a base of 1.0325%. Why the 1 is there? Because it means you're not losing it, right? That 1 represents 100% of your money initially, right? And then it's kind of going up by 3.25% each time you compound it, basically, is what's going on there. So they took the annual interest rate, and they're going to divide it by how many times you're compounding. So we can answer B, A of 0, A of 4, A of 8, and A of 10, all right? So let's just do that real quick. A of 0 is going to be 100,000 times 1.0325 raised to the 2 times 0 power. But what is 2 times 0? 0. What's any number to the 0 power? 1. So it's just 100,000 times 1, or 100,000. It just basically means at year 0 when you're investing, how much money are you starting off with? The amount of money that you put in, right? So this is just $100,000. So I'll just write starting amount. A of 4 is 100,000 times 1.0325 raised to what power? 2 times 4, or the 8th power, right? So I'm plugging it in, yes.
So it's 4 full years, but we're doing it semi-annually,
Right, so that's kind of being taken account here by dividing our rate by how many times, right? And it's taken into account here. So 2 times 4, even though it's 4 full years, but it's twice a year, we're doing it, compounding it how many times? 8 times. So your new exponent becomes how many times you're actually compounding. Does that make sense? So like here it's 0 because we just started off with it. Year 0, nothing's happened so far. But here after year 4, we've actually compounded it 8 times. So in your calculator, guys, you can type it exactly like this. I wouldn't do 2 times 4. I would just write or type 8 in your calculator. All right. So in your calculator, do 100,000 times 1.0325 to the 8th power. And what do you get when you do that? What do we get? So it starts to kind of show you what the growth ends up.
129.
And then raise it to 2 decimals.
0.75.
Perfect. So what does this mean? It means in 4 years it grew from 100,000 to over 129,000. So that difference is the interest that you earned. Does that make sense? And now that you've typed it in there, all we have to go and do for part A of 8 and A of 10 is to exchange the exponent to our new exponent, okay? And be careful, it'll always be 2 times whatever your year is, right? So when we go do 8 of 8, it'll be our 100,000 times 1.0325 to the 2 times 8 power, or the 16th power there. This is what I got, so double check. I got $166,817.25. Does that look right? So it's nice because you can do like second entry in your calculator and just change the exponent. So A of 10, after 10 years, you will have compounded 20 times. So this will be 1.0325 times 2 times 10, or the 20th power is what I would type there. I'm going to kind of put a line through it and say 8, this is 16, 20. When you do that, I got 189,583.79 cents. Is that okay? So in 10 years, we almost doubled, right? Like we were close to $90,000 in interest alone. So this is why they always say, when it comes to investing, like time's the #1 thing. Like if you're not sure if you're gonna have enough money, you start now. Put money away now, and the time's the biggest thing that it'll have on it. All right, are there any questions on the page 3? So your homework will have you kind of set up the generic, but then use that generic to answer questions. So on the back, guys, page 4 is the last little tidbit. It's about a special exponential function called e. So you know how pi is a number? E is a number, which seems weird because you want to fight me and say, no, that's a letter. No, it's a number, okay? So the number e is a very important number in mathematics. It actually shows up a lot in nature. Has anybody taken like a life science class about decay, growth and decay at all? You use the number e a lot. Like certain metals decay at a different rate than other metals and so forth. So the base e is kind of cool. So it was discovered by Leonard Euler, is how you say his name. And so he named it e. How convenient. Why do you think he picked e? The decimal representation of e does not terminate. So it's like pi. You know how people pride themselves on how many decimals of pi they can memorize? E is the same idea. So it's 2.718-ish is usually what I remember. So I usually remember about kind of close to 3 is what I keep in mind. So both pi and e are pretty close to 3. So what's nice is the first couple questions, guys, are just have a rough idea of what e is when you raise it to certain powers. And we actually have the e key on our calculator twice. And I want to point out the difference, okay? So over here, I know it's kind of glaring, right above your division is simply the number e. I don't use that one because we rarely want e just as e. We usually want him as a base, raising him to some power. So if you look over here over the natural log, so ln stands for natural log, do you see e to the x there? He is nice because if you choose him, it automatically goes to the exponent and you can type the exponent. So if we want to find e to the 3rd, I'm just going to hit second ln, and what you're going to notice is that it automatically does the caret and then whatever exponent you want to raise it to. So we want to raise it to the 3rd. And we want to round to 4 decimals, so this will be 0.0855. So this is 20.0855. So keep in mind, e is a little bit smaller than 3. So 3 to the third is 27. So e to the third is not as large. All right, e to the negative 0.23, just do the same thing. Hit the second ln button and then just type negative 0.23. Did you guys get 0.7945?
Yeah.
And then the other two we don't even need to type in our calculator. What's anything to the 0 power? 1. And then what is e to the first to 4 decimals? Just come up here. It's going to be 2.7183. Is that all right? If you didn't know it, that's where one instance you can just type e there. So second e, that is just the number e. He'll come up. All right, so what's his graph look like? Well, he follows the rules of the graphs that we did before. So 0, 1, notice 0, 1 is a point on the graph. And when he's a normal E, we're graphing 1 and then 2.7-ish, right? And then 1 and like 1/3-ish because he's kind of like 3. And then over here, remember a negative is reflected about the y-axis because it's up inside it. So we just flip-flop it. So 0 to 1 still there, but then we're graphing, if you put a negative 1 in there, it makes the exponent positive. So it's just 1 to the E, you know, and then so forth. Okay, so here we're going to do, this is kind of like what we're going to see in the test, I think, is we're going to graph the normal function e right here and kind of get an idea of what he looks like and then talk to each other about what's this plus 3 up in the exponent do. So let's graph the parent function. Y equals e to the x. Who's always on there? 0, 1. So graph 0, 1. Who's always on there? The reciprocal. So 1 over e is roughly 1/3. So at negative 1, just kind of roughly go up 1/3. And then who's also always on there? Well, e to the first power is roughly 3. So 1 and then go to roughly 3. And you guys just graphed e to the x. And notice our horizontal asymptote is still y equals 0 because we haven't shifted him or anything. All right, so you guys seem not to forget, which is great. What's this x plus 3 doing it to our graph?
It's going to move to the left.
You got it. So we talked about this, but the exponent is technically the inside of the graph. If we wanted to shift it up or down, we would put a plus 3 down here, right? So since the plus 3 is up on the inside, that's a shift left or right. It's the opposite of what you think. So this is just left 3. So all I'm going to do is go grab these points, right? So this was at negative 1, 1/3-ish. Now I'm going to go 3, 1, 2, 3 over and graph that right there. This was at 0, 1, but now I'm going to go over 3, 1, 2, 3. Now he's here. And this was at 1, 3-ish. So now I'm going to go over 1, 2, 3 and graph him here. And what you see is the exact same line. You guys just graphed the exponential function that's been shifted to the left 3 units.